Imagine a world where computers can solve problems that would take today's fastest supercomputers millions of years. Problems like simulating the chemistry of new medicines, optimizing global supply chains, or cracking codes that are currently unbreakable. This isn't science fiction. It's the promise of quantum computing, a technology that's rapidly moving from the realm of theory into reality. Quantum computing is not just a faster version of the computers we use today. It's a fundamentally different way of processing information. While classical computers use bits, tiny switches that are either on or off, 1 or 0, quantum computers use quantum bits or qubits. Thanks to the strange rules of quantum mechanics, qubits can be both 1 and 0 at the same time, a property called superposition. Even more bizarre, qubits can become entangled, meaning the state of one qubit can depend on the state of another, no matter how far apart they are. These properties allow quantum computers to process vast amounts of information in parallel, opening up new possibilities for computation. But let's be clear, quantum computing is still in its early days. The machines we now have are noisy, error-prone, and can only run for short periods before their delicate quantum states collapse. Yet the progress in the last decade has been nothing short of remarkable. We've moved from simple proof-of-concept devices to machines with dozens, even hundreds of qubits. The race is on to build a quantum computer that can outperform classical computers at useful tasks, a milestone known as quantum advantage. So who's leading this race? The answer is it depends on how you define leading. Let's take a closer look at the major companies and what they're doing in the quantum computing space. We will explore the different companies, their strategies, and help to visualize their approach in simple terms. First up is IBM, a company with a long history of innovation in computing. IBM has been a pioneer in quantum computing research for decades. Their IBM Quantum program has made quantum computers available to the public via the cloud, allowing researchers, students, and businesses to experiment with real quantum hardware. IBM's roadmap is ambitious. They've already built machines with over 100 qubits, and they're aiming for 1,000 qubit systems and beyond in the next few years. IBM is also investing heavily in software, developing the qubit open source framework to help people write quantum programs. IBM is building standard quantum computers with lots of power and letting everyone try them. They're building a massive digital playground and inviting the whole world to come learn how to use it. Next is Google, which made headlines in 2019 when it claimed to have achieved quantum supremacy, the point where a quantum computer performs a calculation that would be practically impossible for a classical computer. Google's Sycamore processor with 53 qubits completed a specific task in 200 seconds that would have taken the world's fastest supercomputer thousands of years. While the practical value of that calculation was limited, it was a major proof of concept. Google is now working on scaling up its technology with the goal of building a useful, error-corrected quantum computer within the decade. Google is focused on pure, unmatched speed. They already have proved their machine could do a math problem in 200 seconds that would take a normal computer thousands of years. Now they are trying to fix the machine's errors. Microsoft is taking a different path. Instead of building quantum computers with superconducting circuits or trapped ions, Microsoft is betting on a more exotic technology called topological qubits. These qubits are theoretically more stable and less prone to errors, but they're also much harder to create. Microsoft's Azure Quantum platform brings together different quantum hardware providers and offers tools for developing quantum algorithms, even as the company continues its quest to realize topological qubits. Instead of building a regular machine quickly, Microsoft is trying to invent a completely new, super stable type of part that won't break or make mistakes. It is harder to build, but it will be much more reliable. D-Wave, a Canadian company, has taken a unique approach with its quantum annealers, which are designed specifically for optimization problems. While D-Wave's machines are not universal quantum computers, they have thousands of qubits that are already being used by companies like Volkswagen and Lockheed Martin to tackle real-world problems in logistics, manufacturing, and machine learning. D-Wave doesn't build a general-purpose computer. Instead, they built a machine that does one thing incredibly well, finding the absolute best shortcut or solution to massive logistical problems. IonQ is a leader in trapped ion quantum computing, a technology that uses individual atoms as qubits. Trapped ions are known for their long coherence times and high-fidelity operations, making them a promising platform for scaling up quantum computers. IONQ's systems are available through the cloud, and the company is working to increase the number of qubits and reduce error rates. IONQ traps individual, real floating atoms and uses them to hold information. Because atoms are perfectly natural, they don't make as many mistakes as man-made parts. Rigetti Computing, a startup based in California, is building quantum computers using superconducting circuits, similar to IBM and Google. Rigetti offers its quantum processors through its own cloud platform, Forest, and is focused on integrating quantum and classical computing to solve practical problems. Rigetti builds powerful quantum chips, but their main goal is making sure the new quantum computers can plug directly into our old, normal computers so they can work together as a team. Psi Quantum, a startup with roots in the UK and Silicon Valley, is betting on photonic quantum computing, using particles of light as qubits. Photonic systems have the potential to be more easily scaled and integrated with existing fiber optic infrastructure. Psi Quantum's goal is to build a 1,000,000-qubit quantum computer, a scale that would enable truly transformative applications. Instead of using electricity or atoms, Psi Quantum uses literal particles of light, photons, to send information. They want to use fiber optic cables to build a massive system with 1,000,000 parts. Amazon, through its AWS Bracket service, is making quantum computing accessible via the cloud. Rather than building its own quantum hardware, Amazon partners with several hardware providers, including IONQ, Rigetti, and D-Wave, to offer a range of quantum technologies. This approach allows researchers and businesses to experiment with different types of quantum computers and find the best fit for their needs. Amazon isn't building its own quantum computer hardware. Instead, they are acting as the mall. They let all the other companies rent space on the Amazon cloud so you can log in and try whichever one you want. So where does this leave us? Quantum computing is still a work in progress, but the pace of innovation is accelerating. Major tech companies, startups, and governments are investing billions of dollars in the race to build practical quantum computers. Along the way, they're developing new materials, inventing new algorithms, and training a new generation of quantum engineers. The first useful quantum computers may not replace our laptops or smartphones, but they will open up new frontiers in science, medicine, and technology. They can help us design better drugs, discover new materials, secure our communications, and solve optimization problems that are currently out of reach. In the end, the story of quantum computing is not just about qubits and algorithms. It's about human ingenuity, collaboration, and the relentless pursuit of the unknown. The quantum future is coming, and it's being built today by some of the brightest minds and boldest companies on the planet.